Well, I guess without any further ado, Joanne, would you like to take it away?
Sure. I guess I'll just start sharing my screen and start. Um, Whoops, that is wrong window. Daniel, do we have a structure for this talk? Should I start with anything or should I just dive into the talk?
I guess whichever is comfortable for
Okay.
your.
Yeah, I guess I'll just get started. Yeah, if anyone has any questions or ever wants to stop me while I'm talking, please feel free to do so. Yeah, so today I'm just going to be talking about sort of my exploration with making creative maps with Clojure and R. So a little bit about me. My name's Joanne. I am a front-end developer at Pitch, which is also what's powering this presentation right now. I work in team data visualization. We don't have maps, but we are in charge of helping people make charts and graphs for their presentation. Yeah, I have some links to my Twitter and my GitHub if you're ever interested or need to ping any questions that you don't have a chance to ask. So I guess a little bit about me and my hobbies. I come. Sorry. Did someone say something?
I think we were getting a little bit of feedback there. So I did a terrible job of this, if I can interrupt you real quick. If we can ask, if you guys do have a question, put it into chat first, and then I'll try and interrupt at a convenient point for you as you're speaking, Joanne.
Cool.
But everybody else, if you could stay on mute so we don't get too much feedback. Sorry. Go ahead.
No worries. So I've been working in data viz for a couple of years, mostly in front-end development, and some of my hobbies include making personal maps for hikes and trips that I've done over the years. And I really enjoy maps because I think they're a really great way to tell a lot of its stories and information in just one picture. So for instance, here you can see a correlation between heat, sort of the temperature of a neighborhood and income. So this was part of an article about how poor neighborhoods in the US tend to be more affected by climate change. So I come from this, I come at this and I'm talking about this through more of a hobbyist perspective. I really enjoy making maps, but I am not I'm not a GIS professional, and I also really wanted a break from web development in my spare time, since I deal with all the fun stuff, all the fun issues of the browser. So that is why I'm giving this presentation today and sharing why I chose R instead of using web mapping. So this is also kind of a shortened version of the talk that I gave at Clojure D, which is posted on the internet somewhere on YouTube, where I basically kind of dove into this world of making maps with R and Clojure because of my homesickness from moving to Berlin last year. But something I noticed while sort of making some of these maps with R and Clojure is that there's just a lot of resources out there. So one of my goals of this talk is to sort of just distill all those resources into one place. So all of you have a good starting point to create your own maps, and maybe a good reference for, yeah, when you start diving into this yourself. So yeah, I guess I just want to talk a little bit about why I chose R. So I sort of mentioned before, I work in the web, and I really wanted to stay away from plotting using web mapping libraries. So I decided on R because the language has a lot of libraries to decode and read geographic file formats. And there's a lot of libraries for drawing data, like ggplot2. And I kind of like the way that it kind of works well with like my brain after writing Clojure for the last couple years. I really like how everything is treated as a list. And since you're working with collections of data, I think that's a really good way to kind of think about programming. So it wasn't too much of a, it was nice to be able to transfer some of my knowledge. So R can also make really beautiful maps and charts. So this is from Flowing Data, a site that kind of aggregates a lot of really cool data visualization sources and kind of condenses it to this one really cool website. But they also have a lot of R tutorials, which is also where I learned a lot of my initial R skills. I think I lost some of my, I think I mixed up some of my slides. So I'm going to improvise a little bit. So this was actually from Will Cohen's talk. He gave the first talk on this sort of GIS and in this sort of Clojure data science series. So some of the trickiest parts I found when working with GIS data was just kind of dealing with all these formats. So in Will's talk, he talks a lot about how to deal with things like how, like, for instance, like PostGIS lets you perform all these spatial operations on these shapefiles and this geospatial data. And R gives you the same capabilities to interact with the same software. But the frustrating parts and why I started diving into Clojure, R is a little bit inconsistent with its syntax, at least I found, especially after working with Clojure for so many years. Kind of Clojure is, I felt, is a little bit more well-designed and a little bit more consistent with its syntax, and something I very much value, but there was a lot of strange rules that I kind of didn't really grasp and understand, even when going through examples and tutorials. And I also found it difficult and maybe a little annoying to do seemingly easy things, especially coming from Clojure, which is why I started diving into Clojure. So R has a library called rserv that basically lets Clojure is a Clojure library that talks to R using an R library called rserv, or also there's other methods that Clojure supports right now, but I tend to stick with rserv. So some really cool things about Clojure. It lets you call R libraries within your Clojure code and treat them as, and you can kind of work with them as basically like you're working with Clojure external Clojure namespaces. It also lets you use key value hash map in the syntax, which makes things a little bit cleaner. As you can see in the R section, there's just a lot more extra text, which kind of it makes it easier to make mistakes. And so also it supports sort of the ggplot syntax. So something that the plotting library in R does, it overrides the plus symbol and lets you basically build visualizations line by line, like you're adding layers. So here you have a ggplot object, you're initiating a plot, and you can add layers to it using the plus symbol. And so, yeah, the Clojure is able to support that. So it really does feel like you're writing R with a little bit, with a few small differences. So switching gears, I guess I would like to show you how I work with this. But I guess before diving into this, I'll be focusing a little bit on shapefiles. So shapefiles are polygons, points, and lines, and also vector files, essentially, or sorry, I'm going to just take a little bit of a break. So there are vector values. So think of shapes, lines, and points. And yes, the last talk given at Scicloj does a much better job of explaining this. So the shapefile also has a projection, which tells whatever library or program how to translate these numbers from coordinates from numbers into 2D values and how they map onto a globe. So I just want to show how a basic example of how to work with a shapefile in Clojure. So here's an example project I have. So if my depths Eden just requires Clojure. I require a few libraries, and so I have a shapefile that I downloaded from an open data site in New Jersey, which is where actually I am right now. So it's a zip file, and it has a lot of, so we're going to be opening the shapefile. There's a lot of extra files that are required as well in order to read it. So I'm requiring a couple libraries. So in these files, sorry, I am trying to remember what I wrote this morning. So sorry about that. So I'm just reading in this file in these 3 lines and then passing it to a function called stread, which then loads this to what is called a data frame in R. So here, base/class is, base is basically R's like global scope or basic functions, and class just tells you the class name of your whatever argument is there. So I also use the summary function to get a sort of an overview of what is in the data frame. So here you can kind of see columns, column names, and then the data that's included. But it only gives you the first couple rows, so you can get a quick overview. So then you can start, once you get your data into R, loaded in like this, you can start asking questions. So for instance, what are the columns that are out there? So I'm calling R, so this is still dealing within the data frame. Sometimes when I'm working with this, it's sometimes easier just to deal with closure types. So using a Clojure lets you transform R into, or translate R into Clojure lists and Clojure types. So here we just have all the column names in a nice list. So we can start also asking other questions. So if we look at the summary of the data,
I think I might have lost you for a second. What is our base class and summary doing here?
So I guess
it was, sorry.
Yeah, I'm trying to. So so I guess I'm trying to. I don't know why it's just blanking on me, but it's basically I think the standard functions that are available in R. So for instance, so this I have R open right now. So this would these are the same function, and I can do or use class as well. So these are
Okay, that's our accessibility.
yes.
Okay, and we're getting our data from there.
Mm-hmm.
Sorry, I'm a much more visual person, so I'm trying to pick up the bits of R that I don't know well, and we're plotting New Jersey. Is that what I'm reading?
We're right now just calling R and getting the return back.
Okay.
So we're just kind of inspecting the data right now. But I guess, yeah, I should actually just plot. Oh my gosh, I completely skipped a step in my presentation. I'm really sorry. I haven't given a talk over Zoom before, and I'm going to be completely honest, it's very disorienting because there's just like not a lot of like human interaction I can see, which is why I'm just a little strange right now. So usually actually what I do when I get a shape, when I download a shapefile is I open it in a program called QGIS. So and I think I've just forgotten how to use a computer. So what I can do here is to sort of get like a visual overview of what the data that I downloaded. And QGIS is a really, really great open source program that is like a GUI interface for a lot of these GIS software, which I have a couple slides that will explain. I was trying to do this thing where I show the example first and then explain it, but I don't think now that I think about it, I don't think it's working as well. So what I do is usually I'll like take a look at the shapefile that I have, just kind of get a good overview of it. And then I can go into R and then start kind of playing around with it. So I had an exercise where I wanted to see this returns all of the water in the state of New Jersey, but what happens if I just want to plot the lakes and just want to look at the lakes? So what I usually need to then do is find what column would I find the lakes, or what kind of water, or what column would I look for? So if I go back to this.
We have a question of, could you
Sure.
enlarge the text size a little bit? Yeah.
Yes. Is this better? Oh gosh.
Yes, that
Emacs,
I think that's good.
Emacs is doing weird things right now.
I think it's very brave of you to do a presentation with Emacs, because even when I don't have people looking over my shoulder and I'm using Emacs, I make some mistakes.
Scale. I've actually I thought I was just going to run examples and I didn't have to do any typing, but now something weird is happening. Oh boy, this is, well,
while that's getting set up, maybe you can kind of talk me through the data exploration bit of this. So
sure.
one of the things that I got lost on here is as you were looking through some of these base functions, and I think they were it looked to me like you were trying to pull out what the specific data was for water. I forget where that was in the file. Is your workflow normally that you will explore the data first or visualize it first? Because to me, I saw you pulling the data up and I was looking through it, and I think I was talking about this a little bit earlier with some of the people on this call, but I don't read data like that cleanly. I have to see it first to go, oh, this is what I'm looking at. So sorry, I can focus my question a little bit here, but do you normally start just kind of reading through the data that way?
No, actually, I do need to visualize it a little bit first. So actually, I can just probably run the code to. So if I were to actually plot everything. Here we go. Just need to run a couple things. Okay. It's taking a little while.
What are we? Oh, it's still loading. Okay. I was like,
Yep.
I don't know what that grid is.
Right. Yeah. So I sometimes do also, I try to do the visualization. I have to get something out there. So usually that's actually why I use QGIS, because I can just do it in 2 clicks. And then I try to use Clojure for the, I guess, other kind of exploration. But I guess it varies depending on how much I need to visualize. Because sometimes I dive into the visualization first, and then I realize I've gone too far, and I get lost in trying to create this good graph when I'm not really sure what I'm doing. So yeah, it's kind of, it varies. But yeah, my example is, everything is loaded and everything's working again. But yeah.
This visualization tool on the right side here, R graphics, is that what I'm seeing? Is that what it's called?
Yep.
So we had a question about some of your development flows. How do you find your interactions here between Emacs, and you said you kind of go back and forth between RStudio and QGIS, and then this is R graphics. That seems like kind of a lot of tools to get what looks like the same thing multiple times. Can you tell us a little bit about that?
So I tend to enjoy, I sometimes actually just stick with R and QGIS, and the Clojure stuff is more of an experiment. So I actually tend to work more in R for this stuff. And then every so often it gets really frustrating to remember how to do something simple, like even reading files. I think there's a couple examples down below where I actually just call R code straight from Clojure, because there's a couple of things that I haven't really figured out how to do in Clojure, but it's the Clojure library is still in development, and there's a lot of stuff that I feel like sometimes, like, if I can do faster, because like a lot of the stuff is just reading files and yeah, formatting strings and things like that, in which case Clojure would be faster.
Sure. Sorry, I feel like I
okay.
broke your flow a little bit there, but you want to kind of walk us into those examples? I think that might be helpful for us to see.
Sure. Yeah. So I guess I had a couple slides explaining what I just did. So maybe that would help. So how these things are plotted and how these things are plotted is through a couple R libraries. So the SF, the Simple Features library, is responsible for helping me read the file and then turn it into a data frame. And ggplot2 is the library, the plotting library that you see. There's also a bunch of other really important data science libraries that you download in this one package called Tidyverse, which is a collection of lots of data science libraries, which includes ggplot2. Something that the Simple Features library does is it also adds a couple of functions to the ggplot2 sort of namespace. So I'm so sorry, this was a better idea in my head than I really wanted to try something new with like live coding examples, and it turned out a little bit messier than I thought it would be. So there's a couple of functions that it adds to the ggplot2 namespace to help you kind of create these plots layer by layer using this sort of vector data. So the software that is kind of powering the Simple Features and GIS sort of, yeah, the GIS tools is, they're listed here. So GDAL helps you read and write these like vector and raster geospatial formats, such as the shapefile. The GEOS library helps deal with spatial types. The Proj library deals with projections, which is a whole other problem. And like I said, I also use QGIS. That's not related to any of the R libraries. It's just an external service or external program that helps me sort of visualize this stuff quickly. So I guess I also want to explain a little bit about the data frame, since some people here don't have a lot of R knowledge. So it's a 2D data structure, rows and columns, and it's used pretty frequently with R for data science. It's kind of like their key data structure. And so the data we're working with, that data that we're importing from the shapefile, gets converted into a data frame so we can apply all these sort of standard R functions onto it. So I guess an example I wanted to run through is filtering out just the lakes and just displaying the lakes on this plot. So this is the column that we want in our New Jersey water data frame to figure out which what kind of water body is it. So if we run, so here the first line, I'm using a Clojure function, the $sign, to help me just get all the unique types of water in the data frame. I like to sort of think of, I should have I sort of, so in R, this would look something like, I'm sorry, my mind's blanking. But I like to think of this as sort of the get syntax in Clojure. And so I wrote a helper function to help me filter by whatever type that we pass it in. So if I were to just, actually, I'll just run the example. So here, we're creating a ggplot object, and then we're adding layers of plotting code to it. So if we just start this off, here we're filtering by all lakes and ponds. So we've plotted everything that's a lake. And then you can apply, you can continue to run functions on the plot to kind of add more layers. So this chord SF is actually a so this chord SF function is a function from the SF library that gets added to ggplot2. So this applies the projection of the first shapefile to the plot to the plot. Sorry. It basically takes the projection of the shapefile and applies it to the plot. And if you want to get rid of the grid lines, the theme void function is really helpful. So now you get something that looks a little bit more like a nice map, although it is a little hard to see. So something I can do is just change the outline size. So it's a little bit.
It looks like New Jersey to me.
Yeah, and there's a lot of lakes. Yeah, and it's. I'm like now trying not to tweak it and just to. I need to keep going with my presentation. Something that I really like is looking at a lot of vintage maps. So I really like these sort of maps that like lay out a lot of grids or a lot of items in sort of a grid shape. So here you're just taking these lakes and rather than plotting them where they are, you can just sort of spread them across a grid. So I am working on an example to get this working in Clojure. So I just wanted to explain sort of this concept. So there's this concept in data visualization called small multiples where you're plotting over the same axes, or you're plotting related data over the same axes, and it's rather than cramming everything into one plot, you break things up into this grid where you can easily compare different like the same visualization over different parameters. And essentially I wanted to apply that to, or use that technique for this sort of data set, these lakes in New Jersey. So
forgive the interruption here.
Yeah.
What from the visualization perspective of this, because that small multiples, as you were talking about it, that I can see absolutely why I would want potentially to visualize that, because I can see, I think from what I was seeing, the gray in the background and then the blue there, right? Mm-hmm. How does this, or sorry, if you could go back to your other vintage map, mm-hmm. What information does that tell me? Because like I look at this and this seems almost useless to me as a map. I can't read this really in any way.
Not a map. Like it's, I guess, different. I mean, I like to compare sizes of the lakes.
Okay.
So you know, looking back at this, I guess you can see what is the biggest lake, but it's kind of hard to get a good picture of what they all. I don't know. I think it's pretty cool to kind of see like all these lakes like in a different view. I guess I'll just run the example and
I can say that sort of that small multiples, that's something which I'm very excited by seeing this. Like this is a really time consuming thing to do it in QGIS manually. You would have to make a bajillion little maps all at the same scale and export them out. But if you're comparing, in this case, lake size or city size or building size or just things from shape to one another, people always like being able to see different locations that are in disparate places at the same scale is like a very powerful visual tool to realize what one thing is from the other. So I think this is super neat.
thank you. Unfortunately, I don't know. This was running this morning. I believe I have I think I have a screenshot of this. This is not working. Sorry, 1 second.
Maybe so while you're doing that, I can direct this at Will. So that it sounds to me like this small multiples is vaguely, I'm much more familiar with textual data, but it sounds vaguely like kind of a heat map or like a word cloud type of visualization where you can kind of see everything in a bag of data almost. Is that kind of the
There's
goal?
a reference that you should look up. There's two of them. Well, there's a bunch of books by a guy named Edward Tufte. One is called The Visual Display of Quantitative Information, and the other one is called Envisioning Information. And in that, one of the principles he talks about for good graphic excellence is this idea of small multiples, that if you hold everything constant except for one thing, in this case, Joanne's telling us about like the shape of lakes, right? Or in the example she was just showing, the exact wiggle of that line. Then once you understand one of the multiples, all the other ones come for free. So it saves the viewer of having to like reinterpret each one of these lakes every single time. So, doing it for graphs is one thing, which R does, but she's like showing us this way of applying small multiples not only to graphs in the way that R like very classically does with ggplot or whatever else, but doing it for maps too.
Wow.
Sorry, this is not.
I understand your excitement now then. That sounds pretty cool.
Yeah.
This was working this morning. I cannot believe it's, this was supposed to actually, I was also really excited about this because this is supposed to be, yeah, sort of.
So are you sure that you have a screenshot of it? Because if you could like take the time, if nothing else, to show us that would be pretty cool.
I have the R version of it actually working for a different, this is for Colorado, for a different state. But yeah, I guess my sort of excitement about this is being able to kind of compare all these different lakes in one view like this, instead of, yeah, like having your eyes like trying to search around like a map for all these different things. You can make a big comparison in just kind of one look. And I also think, yeah, it's just kind of like based on like the original source, I think it's just a really pretty way of looking at looking at geographic data. And yeah, like you never really get to see sort of all these things next to each other. Like for instance, if you're, yeah, like taking all these lakes like in different corners and just like taking away their location and just putting them next to each other. It's kind of like you're, yeah, like just rearranging stuff, but they're real life things and they're very big and you can never do this. I don't know. I think it's pretty cool. But I can kind of explain the process that I made process that I did to make this in the Clojure code.
Sure. Let's walk through that.
Cool. So unfortunately, it's not running as I had hoped, but the way, so you start off with your data frame. So my list of New Jersey bodies of water, you filter out of all the lakes and ponds. So now you have just a list of all the lakes and ponds in New Jersey. But now they're kind of in all this different order. I think the most interesting parts of it are, the biggest ones. So let's say you just wanted to look at the 20 biggest lakes. So I actually couldn't get this working with Clojure. So Danielle, I may have to talk to you about this later. But I ended up, but even though I couldn't get it working, this was one line in R. So I created a function in Clojure or I created an R function in Clojure that I can call from Clojure. So here, I'm ordering by this column called shape area, which is just the area of the polygon. I set the number of lakes that I wanted to see. I filtered them out. So I applied the ordering function. So I used a couple of Clojure's helper functions. So this would probably look like data frame bracket 1 to 20. So this line here, you're just getting the first 20 rows of your ordered list. So yeah, this is what it would look like in R. There's probably cleaner ways to do this with threading. I think this worked all right for now. So yeah, this one was able to run. So now, whoops. I'm so sorry. I think Clojure just, Emacs just sort of exploded again.
So while you're getting in there, I want to apologize to your beautiful vintage map because I think I was thinking about it the wrong way.
Oh, no.
I was imagining it more as like a navigational. You say map, I think navigate. Like this is how I get from here to here, and I learned a lot already in between you and Will that how I'm thinking about map data was wrong. So thank you for teaching me something. And,
No.
what you're back up, so I apologize for the interruption. Go ahead and keep walking us through.
No worries. But I used, I guess the biggest thing here is I used an R library called cowplot to help me plot this out. And this was still a work in progress in translating this to Clojure because but basically I'm taking every row of, gosh, I'm a little bit flustered still. But I created a plot with the top 20 biggest lakes. And then I found their centers using the SF library's centroid function. And now it's connecting, or I just started up the session, so it froze a little bit, but I can keep talking. So with the center, that becomes like the center of the new plot that we're creating. So that way it can kind of figure out what the boundaries are. Oh, and I found another Clojure bug, Daniel, that we can talk about afterwards. Using the centroids, I can create basically boundaries for every lake that there is. And then using a couple functions, I use cowplot to plot out this grid out here. That's a very high level overview, but I'm happy to answer any questions if you're also curious about the details, or I also have this, all of this is all on GitHub if you want to copy and try to run these yourself. I think I wrote much better comments than I am, and I think I'm better at writing things than I am at explaining, but I'm happy to answer any questions.
Would you mind sharing that link in the chat so
Yes.
anybody here can just click on it?
Mhm.
I think we've got a question in chat. I'm not sure I understand it though. So if,
Oh, sure.
I'm not following it. Do you guys want to bring that discussion into chat or into voice? Maybe not. All right.
Oh, no. Which question?
Oh, I was just looking at the last one. Apparently, I missed a few. I saw some chat about Edward Tufte, and then would guess the small multiples would be ordered similarly by polygon size, like the river example. Are we talking about just data visualization here? Yes. Okay.
I think I missed some context.
I think I am too.
Yes. There's Will Cohen's. Yes, that was actually another inspiration. I think there was also another. If you click on the, oh yeah, I'm sharing my screen. So this is a hand-drawn map where all the rivers are straightened out. And yeah, it's hand-drawn and it's also exaggerated. This is also another thing where people sort of take artistic liberties with sort of geographic representations. So yeah, also when like something else to keep in that I've sort of have with like stuff that I do, like my personal hand-drawn maps, like all of this is all up for interpretation. So actually I have another example that I didn't want to get into because I don't think it was really relevant about simplifying lines. So for instance, if you,
But before you go on too much further, I'm intrigued by your comment about open to interpretation.
Mhm.
And so my understanding, I do have a little bit of experience with GIS, but there's certain ways of representing the data, but I wouldn't necessarily say it's open to interpretation, right? Like the lake or the rivers, I guess in that case, are what they are, and now you can use different projections to represent them visually. But can you elaborate a little bit on how you mean open to interpretation?
I guess I wanted to, when you were asking that question, an example popped into my head about these election maps. This is, yeah, I think this is a pretty good example where you have things that are kind of geographically in the right place and you can see the shape and it looks like the US, but this is something where the shape is open for interpretation. And for this, like this sort of example lets you see like, yeah, lets you see the data more clearly rather than seeing like a more literal interpretation of a map. Whereas here, yeah, this is if you drew everything point by point and geographically correct, you kind of, it's harder to compare the length. So things aren't maybe stretched, they're not stretched out, but they're just kind of straightened a little bit. So you can kind of compare it, you can compare the lengths of each river. Does that sort of answer your question?
I think so. So I guess how I was picturing this more is like each of these rivers, the distances have been calculated correctly, right? So you know, based on whatever projection on a map, a river can appear much longer than it actually is, or it can appear to be its actual size. So all of that has been, I don't know, has been calculated and sorted out for this, and then it's the open to interpretation part of this is it's kind of been straightened out into a line to represent how its length would be compared to the river next to it. Is that a good summary? Does that make sense?
Yeah.
Okay.
Yeah.
Okay, so I think I'm with you now. Thank you.
Cool. Were there? Oh, Jesus Gomez wrote a question about changing the L apply to something Clojure native like map. And no, you can't use, unfortunately, you can't use Clojure native functions on data frames. But you can, something I do is like occasionally take things out and convert it to Clojure, and then run Clojure functions there, and then stuff it back into the data frame.
Is that a normal interaction if you're going between, you know, more of an R workflow to a using R and Clojure, that you just kind of mash it out to say, hey, put this data frame into Clojure native stuff, do my operations, mash it back into the R data frame?
I would say it's probably not performant, but I don't know if there's really a normal workflow for this because it's still kind of in development and still a bit experimental. So anything to your imagination, as long as
Sure.
your computer runs.
I was curious more as to your workflow, what you do with it. Is it, you know, you just say, hey, I can't work with your R stuff here. Give it to me in Clojure. All right, cool. Do my stuff. Get it processed how I want. All right, here you go, R. This is now what I want. But I think Daniel may be the person to ask a more intelligent question about that than me.
Yes, that's like I think I'm just I guess a user of this library. I think Daniel has more insight or a better person to ask about this.
So I did interrupt you. You were going to give us an example that you said may not be super relevant to your presentation, but then you thought it might have been.
Sorry, I also forgot to send this to everyone. So I guess I sort of a, let me see if I can get the example out. Here we go. Nope, I am. This is strange. Okay, I guess my examples are not working right now. I might have overwritten them. But I did sort of have an example about simplifying lines. So for instance, you may not want to have this sort of fine detail. Sometimes you just want like a visual representation. And I guess it kind of goes back to that election map I showed before, where you have just sort of an abstract shape, and you have a general location of where it is, and that's good enough. And it sometimes is a good thing because you can actually, like when things are, yeah, like for instance with election maps, like when you see like a big blob of red or blue, your mind thinks, oh, okay, this is bigger, so thus this has more value. And so when you sort of take away some of the detail, you can describe other stuff or describe other data without having like other things sort of hinder your interpretation. So for instance, with things like a river, like you may want to simplify a representation of the river when you're like, say, like measuring like river flow or visualizing river flow. Like maybe too much detail and too much squiggliness can sort of distract your eye a little bit. Although, yeah, I don't know if that's not quite a real example, but I think the election map was a much better example of that. I just got another question.
I was on mute. That's what I was reading out loud to myself, apparently. You go ahead and answer it.
So how constrained are you in terms of graphic manipulation using cowplot or ggplot? I have a slide sort of saying, so something that I sort of talked, I was thinking about this a little bit, like when writing up these examples and sort of where I'm at with these. I feel like everything I produce out of R and QGIS and just all these, like I've tried a lot of different tools and everything still feels kind of technical. And I think it's because I still need better graphic skills. Like it still, I sort of want to go, I'm exploring these things because I love drawing maps so much and sort of doing this for like out of personal pleasure, but I feel like I'm really limited by, and I want to see if I can do this with software, but I feel like I'm a little bit limited by, a little bit limited by R. But something that a lot of people do is that they import their R, everything, so you can import or export stuff that you generate in R into vector formats. So you can open this up in Illustrator or other image editing software. Like even the example that with the small multiples I showed you, I'm pretty sure had, like this was generated in R, but sorry, I'll get rid of this. This was generated in R, but I'm pretty sure there was some Adobe Illustrator applied to this to just make it look a little bit more polished. But in terms of, if you had wanted a spiral, actually, I think a spiral would be possible because it's sorry, I should not use the word just, but it's placing things on a spiral is math. So that would actually be a really nice use for something like R, because you kind of have, you can do this using, you can plot like things in a center. At least I've done similar things in D3. But I haven't done this in R before. Daniel, I think it might be nice to look at the R code in RStudio environment. Okay, yeah. So I guess there's really not, I don't know if there's much really special about my R flow. I mean, what I really like about R in RStudio is that I downloaded RStudio and I opened it and like my code is there. And after years of messing with Vim and Emacs, I really like just kind of having everything work in one window. So I tend to, for instance, require all my libraries at the top. I just use Control Enter to just run my code. I definitely try things, or I try things out in the REPL. So with things like plotting, like I definitely like to play around with attributes. And I guess this is also something where I really like, actually, no, I already have a parameter for this. Something where I really like Clojure, but that's the same value. What am I doing? Something where I really like Clojure because this kind of gets, it can get kind of messy and big, and not having my editor of choice is a little frustrating.
I think we've actually got a follow on to that fairly nicely from Andrew, which is I use R mostly, and there are ways to get many plots together. A couple of examples, and with Clojure, are those kinds of things easy to do? And then following up with that is for data viz, what is best, Clojure or R? I guess which have you found easier to use or produce visualizations with?
I still very much prefer R for just creating output. I guess my question to Andrew, have you used anything or any sort of visualization library in Clojure? There is a library out there. I forgot the name of it. Or am I getting replies? Sorry.
Yeah, I think there's a few different options with Clojure, but what I hear in there, which makes me sad, is that R still has some advantages over Clojure, at least for what you're doing. So sounds like we have some work to do, Daniel.
It's hard just because R has, like, they've been sort of pushing this open source community, and like it's used by basically non-programmers and scientists for years and years. And there's also just kind of like this, like the package management system is also like, there's like the strict submission guideline, and yeah, people are using this for papers. So it's hard to compete with that. It's also the same with Python as well. Did I miss any questions?
So before we go full on into the Q&A, is there anything else that you wanted to continue with? I saw a few more slides, but if you're comfortable with where you're at,
I think this is a
presentation.
I think it's a good stopping point. I had a bunch of slides about, this is going to go into a little bit about raster files, but I think just focusing on one thing is enough.
Sure. Okay, then opening it up to our audience. You're welcome to continue asking in chat. We'll definitely keep an eye on there, but feel free to come off mute and give us some real human interaction. I think I did see one come in. Are there any other examples out there for cowplot maps apart from visualizing US states?
I guess cowplot is mostly used for I guess things like this, or like the example I showed. Although I don't know if
is that largely like a scatter plot, sort of.
No. So I guess when it's just basically for anything in a ggplot axis. So yeah, you can just there's different ways of putting stuff into grid, but for the most part, yeah, people put things like scatter plots and line plots.
Sorry, maybe I didn't ask my question well. The map that you showed for the US states, in which the states were not limited by their size, but their locations. That's what I meant. I thought that was the cow plot.
Oh, no. I think that's something else. I don't know how those were generated.
Okay, because I think the US states have straight boundaries, so that's much more, that kind of a map is much more amenable to America. But like for India, the provinces and the boundaries are very haphazard. So I don't know what are the other examples where those kinds of maps were used.
I don't have it off the top of my head, but Europe has one. I'm trying to remember where.
So, Joanne, what was the name of the plot exactly? I think I didn't. Is there any specific name for those kinds of plots?
I don't know off the top of my head. I don't know if anyone else in the chat knows. I'm just Googling.
Specifically of the map that was not, the boundaries, but like the circles and locations that vaguely represented the shape. Yeah.
Yeah.
I would maybe throw that one out to Will, our
You mean the
data
what?
viz expert.
You mean the one that's hexagons?
Yes, exactly. Yeah.
Oh, yeah, I'll figure it out. I know what it is.
There's a couple there was one I saw for Europe. Are they cartograms or cartograms?
That's it. That's the name. That's it.
Cool.
That's totally it. Yeah.
Thank you.
I just want to see if I can find the Europe one. Just to, because I tend to show a lot of US examples, but yeah, it's been done for other large land masses that are not in the United States. Any other questions?
I have a question. I don't know if I'm coming through.
Hello?
So sorry, I'm Andrew, the person annoying.
I think you're breaking up a little bit. Cool.
I have kind of a off-topic question from where we were at while Andrew asks. So you said you're a web developer by trade, is that right?
Yes.
What motivated you to get into R? Just something different? You wanted to build these visualizations and you were like, hey, this is, when you Googled it, it just popped up as the first great thing to do, or what was that path?
Whenever I made, I don't do so much like one-off visualizations anymore, but when I used to, I used to use things like, I was playing around with R and Python and trying to figure out which one was the best, because sorry, let me rewind. When you're creating visualizations, there is like an exploration step where you need to just kind of make a bunch of visualizations really quickly. And I kind of think that like web development is really poor for like exploring data. Because like my job is not just like my job isn't just like putting stuff on the screen and making it performant. My day job is putting stuff on the screen and putting graphics on the screen and making it performant and run well and also look nice. But when you're exploring data, the purpose is to just get as many visualizations out and explore and like see the data from different perspectives. And R and IPython, or like the IPython notebook environment, and even Excel spreadsheets are really, really good for that. And yeah, also and truly, like sometimes I am really, like I just want to get away from the browser a little bit.
Yeah, I can understand that. So we got two in, but I'm going to throw it to Andrew's question first. Are in Clojure advantages and disadvantages of each? Ooh, broad question. When would you prefer each in regards to data viz, and what could I gain from Clojure that I might fail or find harder or lack when I use R? And in your opinion specifically.
I think they're different tools. I mean, right now, like they're different tools, and I think what Daniel is building with Clojure is like a really awesome way to try to bridge the two, because yeah, like I think R is a very well designed language that I really enjoy. Oh, sorry, Clojure is a very well designed language. I really like writing Clojure. I think, and R has like a lot of really great libraries behind it, but I think it's a little bit clankier than Clojure. And in terms of data viz, the really good thing about R is that it really just takes a couple lines of code to get something on the screen. Whereas I don't know. There are libraries out there to generate graphics in Clojure, but they're just not as well developed. You can download a CSV from the internet and download RStudio and get the stuff into a graph within 10 minutes, even if you're just copying examples from the internet. I think that's a really big advantage to R. So yeah, and then also, yeah, like I think Clojure is also a harder language to get started in, but something I really enjoy with Clojure is being able to think functionally and being able to think about filtering data really quickly and just pulling out answers that I need. For instance, I was actually developing a coding challenge for our team, and I was just testing it out, like writing everything in Clojure script, kind of just, and then I found out that, yeah, like it was actually quite easy to get something up and running if you just like do the hard work of, setting up an HTML page and it's just easy to pull out data that you need. I'm rambling a little bit, but I'm done with my answer.
Still on mute. I thought that was actually kind of an interesting answer. From what I heard, you say is R is very easy to put something on the screen, right? Generate these visualizations.
Mm-hmm.
But Clojure is actually easier to explore the data with when you're like, wait a minute, I need to work with this and let me filter it out, and those types of operations. Is that a fair summary of your statement?
My personal opinion is that I don't know if a lot of other people would agree with me. I'm also quite fluent in Clojure, more so than R, so maybe that's why I think like that. Like I tend to always forget R syntax, no matter how often I work with it. Even though I don't work with it professionally, I always forget how to do things, like just even like applying a function to a column. Like I just keep forgetting. Whereas, yeah, Clojure just has this really elegant, consistent syntax. If you need to apply a function to a list, it's just, it's kind of built for that.
I think that actually might even lead us into the next question from Jesus, which is, I was thinking that Java is already a famous language in the GIS ecosystem. Have you ever thought about exploring the Java GIS libraries and using a Java interop? I can say the last experience I had with GIS was entirely in Java, and I didn't even know Clojure at the time. So I would be interested. Have you ever tried that?
I'm pretty sure I tried it. Yes, but I don't remember much from it. Yeah.
Or it was traumatic and you blocked it out?
So I do this stuff for a lot of this stuff for fun because it's like a passion for me. So if something is like kind of a bit of a roadblock, I I'm kind of the type of person who, like, professionally, of course, like, you get through it, but then if you're trying to do something for fun, sometimes I'm just like, no, I don't want to spend 3 months trying to set up this environment, or sorry, 3 months is exaggeration, but yeah, I just want to get something up.
Do we have any other questions?
I do, someone mentioned, yeah, like native Clojure functions on data frames. Sometimes, yeah, sometimes I really, yeah, like I pretty much have to like balance two languages or figure out two languages in my head and kind of do this translation, but it would be nice to have a more Clojure syntax for, say, like, yeah, taking 20 rows from something, or yeah, taking a range of something, or yeah, applying a function to something.
Yeah, I think that was the answer to Jay's question there, right? What's missing between R and Clojure.
Oh, yes, I'm sorry. Is my chat window visible, or?
I see some strange dotted lines, so
Okay, because
I don't know what everybody else sees.
oh yeah, Zoom masks the chat window. So I was highlighting the question. Thought I was being clever, but unfortunately that didn't work.
I guess that's an interesting feature. Anybody else? Just gonna give it just a minute. But thank you for giving us this presentation. I personally am also interested in maps, and I wouldn't call myself any, I guess I don't know the word, cartography nerd, but they're always enjoyable for me to look at. So I had a good time, and I know it was a little bit of a struggle with Emacs. I blame Emacs for any type of presentation problem and the demo demons that always get you, but I thought it was great.
Thank you. I put a lot of effort into this sort of example directory. I think, yeah, these examples kind of speak a little bit better, because I've also haven't given a talk over Zoom, so I was mentally just not really understanding what was going on. I'm just speaking into my computer. So
yeah, interesting times we live in, where we have presentations that's also like a chat application where you expect just going back and forth. But no, you did great, and it was my first time moderating our chats here. So
awesome! You did a great job moderating, and
well,
thank you for all your questions, everyone.
Yeah. Well, I guess I didn't see anything else come in. So if I think Joanne, you're in our Zulip chat, right?
Yep.
So if anybody can direct any other questions there, and follow Joanne, I think you said on Twitter, if you want to throw that up one more time. I think it's on the screen there at Joanne Cheng.
Yes.
And I know I personally am going to go start playing with some of these libraries. I have a lot to learn about R, but now I am more motivated. So thank you for inspiring me to do that.
I promise I'll fix the examples too. So maybe wait 20 minutes or.
All right. Thank you for your time, everybody. And thank you, Joanne.
Thank you so much for listening. Thank you.
Bye, everybody.
Bye.